So in this video we're going to find sine pi plus I natural log of 3. Now that's a crazy looking input for the sine function there. Complex analysis of course with the I in there. So how do we start evaluating what this is? So we can see straight away that the sine function is in this format, A plus B. So it looks like we're using the double angle formula for sine, where we've got a pi and an I natural log of 3. So we'll denote A equals pi and B equals I natural log of 3. Now the double angle formula for sine is sine of A plus B equals sine A times cosine B, and they are multiplied together, and add them with cosine of A and sine of B. So a nice easy formula to remember there. It's just sine and cosine and then flip the A and the B around each time. Okay, so we know what our A is, we know what our B is, so let's plug that in here and see where we come to. So sine of pi plus I natural log of 3 equals, now we're going to need quite a lot of room here, so sine of A, so sine of pi times cosine of B, which is I natural log of 3, and then add cosine of A, so cosine of pi, and multiply that by sine of B, I natural log of 3. Okay, let's see where we're up to now. So we've got sine of pi, that's real, cosine of I, something that's obviously not real. Got cosine pi here, and a sine of something here that's not real. So this is real, this is real. So let's work out what we've got here. So sine of pi going on the unit circle. So sine is our, let's say the y-axis. Go back to real analysis here rather than complex analysis. So y and x, sine is the y-axis and this will be the cosine. So at pi, so if we go around pi, we're here. So sine is sine of pi equals 0, and cosine of pi is over here, unit circle radius 1. So cosine of pi equals -1. So sine of pi is 0, so we don't have to worry about working out what cosine I log of 3 is. They just cancels out because that's 0. Cosine pi is -1. So let's see what we've got here now. We can plug that in. So we've got -1 times sine of I natural log of 3. Okay, so -1 no problem. Sine of a complex number input for sine, so there's an identity for that. So what we do know is that sine of IZ equals I times sinh of Z. So you just take the I out, exchange it for the hyperbolic sign, and then the Z will stay in there with the sinh. Okay, let's plug that in there. So that equals, so the I can come with the -1, so that's minus I, sinh, and then the number we need is the natural log of 3. Okay, sinh of natural log of 3, how are we going to work that out? Well, we know that sinh in exponential form is 1/2 e to the z minus e to the minus z. So if we let z equal natural log of 3, so z equals natural log of 3, we can then plug that in there. So that equals 1/2 e to the natural log of 3 minus e to the minus natural log of 3. Okay, this is good. E and natural log are inverse functions, so they can cancel out each other, and the same again. e and natural log here can cancel. So now we're left with 1/2 times, now we're just left with 3 minus, and then we've got, careful here, we've got -3 here, so we don't just put in -3 because it's a negative, it's 1 over, it's reciprocal. So that's 1 over 3. So that equals 1/2, 3 minus 1/3, well 3 is like 9 over 3. So 9 over 3 minus 1 over 3, that's 8 over 3, which equals 8 times 1 is 8. 2 3s are 6. So that equals 4 over 3. Now we're still not finished here, we've just worked out what sinh of natural log of 3 is. We need to plug in the minus I in there as well, because that's a multiplication. So then that gives us minus I times 4 over 3, which equals minus 4I over 3. So starting off with this crazy input here for sine, we come to the end of minus 4I over 3, which is our answer in Cartesian form. So on the plane, let's just draw that up here quickly. On the complex plane with imaginary here and real here, the real input is 0, so it's going to stay on the imaginary axis. So minus 4/3 I, so it's going to be there, minus 4/3 I. Obviously radius equals 4/3, and the angle is minus pi over 2. So we could write that also in polar form as 4/3 e to the minus pi I over 2. That would also give us our same answer. Okay.